So we're going to be going over the area between curves, and we have two graphs here. The blue one is y equals the square root of x, and the black one is y equals x squared. And they meet at 1, 1. So I should write that. Cut that out. So they meet at 1, 1. Oh, what we're going to be doing is trying to find the area that's between them, which would be this. So what we would do is find the area of y equals the square root of x, which would be all of this, on the bound, and try to find and subtract it from the area of below x squared, which would be this. So what we would, an equation for this would be the integral from 0 to 1 of the square root of x dx minus the integral from 0 to 1 of x squared dx. Another way you can write this would be this integral from 0 to 1 of the square root of x minus x squared dx. This would be the equation, because cut that out again. So this would be the normal equation for all area between curves. So, and this is just an equation that's been
Yeah.
So this would be the equation for all area between curves. And the square root of x is first because it is the upper curve, as it is going up above x squared. And x squared is the lower, so that's why it's second. And the rule is upper minus lower dx. That's how you find area between curves. And then we have to cut that out. So to evaluate it, we have to do the antiderivatives. And the antiderivative for the square root of x would be x to the 3/2 over 3/2, which would be the same thing as multiplying by 2/3. Evaluated at from 0 to 1. Minus the antiderivative of x squared, which would be x cubed over 3, evaluated at from 0 to 1. So if we evaluate x cubed, x to the 3/2 times 2/3, it would be from 1, it would just be 2/3. And evaluated at 0 would be 0, because 0 to anything is 0, minus x cubed over 3 evaluated at 1, which would be 1/3, minus, and x cubed over 3 evaluated at 0 would be 0. So that would just cancel, and it would be just 2/3 minus 1/3, and that would equal 1/3. And that is the area between the two curves.